Hey everybody, and welcome back to more of the 2001 Grade 11 Fermat competition put out by the CEMC. We're on to question number 12, which is an interesting little inequality question. And it says, how many integer values of x satisfy x minus 1 over 3 is less than 5/7 is less than x plus 4 over 5? Okay. So when I see multiple inequalities in a row, like A less than B less than C, what I usually try and do is break them up. So we have x minus 1 over 3 less than 5 over 7. We need that satisfied. And we also need x plus 4 over 5 is greater than 5 over 7. We need to satisfy that one. And if we satisfy both, well then we happen to have satisfied the whole line there of x minus 1 over 3 less than 5/7 less than x plus 4 over 5. So we'll break them up into little pairs and we'll see what we can do from there. Okay, so we grab our pen and we grab some paper. And we're looking for integer values. So x minus 1 over 3 less than 5/7 less than x plus 4 over 5. So we take the first one. So the first thing we want to do is find all integer values of x that satisfy this. And then we're also going to do the same thing with the other one. 5/7 less than x plus 4 over 5. So the blue one will give us a range of x values, and the red one will give us a range of x values, and when we combine them, we should get some overlap or some exclusions in some way. So we're going to take our first one here, and I don't like fractions, so I'm going to multiply both sides by 21 to get rid of it. Why 21? Because we have a 3 over here and a 7 over here. So since I'm multiplying by a positive number, the inequality in the middle does not change. If it were a negative number, it absolutely would change. Okay? 21 divided by 3, that's going to be 7. X minus 1 is less than 21 divided by 7 is 3, so that should be 15. Okay? 7x minus 7 less than 15. And so we'll have 7x. We add 7 to both sides, we'll get 22 over here. So x needs to be an integer less than 22 over 7. And that's just a little over 3. So any integer less than or equal to 3 will satisfy the blue equation. And if we wanted to, we could check. So let's pick an integer less than 3. How about 2? So 2 minus 1 over 3. 2 minus 1 over 3, that's 1/3. Is that less than 5/7? Yes, and if you don't believe me, you can grab your calculator and check. 5 divided by 7 minus 1 divided by 3 is going to give you a positive value. So you know that 5/7 was the bigger one there. So we have some integers that satisfy the blue equation, or the blue inequality. Now we need to get some that satisfy the red inequality and see which ones are in both lists. Okay? And the ones that are in both lists, the ones that satisfy both inequalities, will satisfy our original inequality. Okay? So 5 over 7, so we've got something over 7 and something over 5. So a nice little common denominator or something to multiply both sides by would be 5 times 7, which is 35. So 35 times 5 over 7. Put the little dot in there so we know it's multiplication. Now since we're multiplying by 35 and 35 is a positive number, we know that the inequality in the middle is not going to change signs. Okay? And this becomes 25 is less than 35 divided by 5 is 7. 7x plus 4. Okay? So 25 is less than 7x plus 28. Okay? 7x plus 28. So if I wanted to just get all the x's on one side, I would subtract 28 from both sides. So that's going to give me minus 3, because 25 minus 28 is minus 3. So I need minus 3 is greater than 7x. Or sorry, is less than 7x. Divided by 7 on both sides. So I'm looking for all x values here. Well, this is just below 0. It's a negative number, but it's not quite up to -1. So it's just below 0, so I can say if I want integers, I'm looking for x greater than or equal to 0. So I combine both statements. I'm looking for 0 less than or equal to x less than or equal to 3. Again, once we get this 0 less than or equal to x, we could check and make sure. Let's take 0. 0 plus 4 is 4 over 5. 4/5, that's 0.8. And 5/7, I don't remember that off the top of my head. 5/7 is 0.7. So that is definitely less than 0.8. So all of these work. So let's just list out the ones that are integers. 0, 1, 2, 3. Therefore, there are 4x. 4x's that work. So, was 4 one of our answers? Oh, you bet it was a potential answer. It's this one here on the end. It's E. So we have our answer of E here. And we're ready to move on to the next question, which is 13. It's got a little cube in it, but we'll take a look at that in the next video. So as usual, thank you guys so much for watching. This has been question number 12 on the 2001 Fermat paper, and I'll see you guys next time.